Media call me a menace. I said with the media politics, I'm gonna change the image. You can't blame my pants no more. I could put it in. Some said I'd never be a superstar, but I know I'm different. I'm a voice. The system making me choice. But the people that come on board, I know I'm trying to support. Yeah, support, tell me support. Or visit, I'm going to courts. What the hell is standing me up? You know that I'm famous. How you gonna joke about them? But they really get game to touch. I know something on her face. Stop trying to take drugs. I hurt myself. Trying to better myself. Trying to better my health. But trying to keep it down. It's hard. Thought I could get out. Oh no. 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 Down. First generation, whole world, hello, made it out of the city with my head on straight. Feet, to let out. Yo, Joe, the pill gotta get out. Did I spit out the G code like I'm facing a Rico? I had to put it out. And another one, and another one. I got like 100 about a left. They did, but I'm really in front of them now. Some of them, they bad. Whatever little confidence they had, a reminder of humble yourself. Cause he's going in an instant. Me, I'm running on distance, all distance, fire. I've been typically maybe retired and feeling like I'm tonight in my prime. These days, team members be dying, waiting for age and getting they shot. I never even heard a little buddy. Cause somebody heard a little buddy. Now I'm on the phone searching a little buddy, man. You gotta play the tones all day in my phone. Thinking, damn, we can get their names, but just gotta go land a tone. Immediate people click. I got a new rule. If you ain't never posted a rapper when he was alive, you kick about him after he get hit. It's simple. It's a principle. I'm simple. I'm invincible. Don't even rap my shit that you I rather that in an interview most days. All in
Okay. Hello. 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 Yes, bro, can you hear me? Hello.
Yes, I can hear you.
Yeah, we shall right away start off. As we wait as others join in.
Okay.
Now, in this, okay. So, yesterday we were able to cover network layer protocols. So today we shall start with the introduction to IPv4 addresses. IP stands for Internet Protocol. V4 it is version 4. Okay, so what's an IP address? IP address identifies a node or an interface on a network device on a network. IP addresses are used to forward IP packets on the network. So with the help of the IP address, we are able to send information from to send information from the sender to the receiver. So here they're telling us an IP address identifies a node on a network and is used to find the destination for data. So without the IP address, we can't be able to transfer information. You get, so here they are trying to show that our colleague here is stuck. He wants to send information, but he doesn't know the destination IP address. So from the previous classes, we realized that there's a protocol we use to find out the MAC address, the physical address of the user, of the receiver, whoever you're sending information to. So we use that protocol is called the ARP, Address Resolution Protocol. How it works, I will send you to the to go to and check out those other links for the previous classes to understand that in detail. IP address notation. An IPv4 address is a 32 bits long. It is dotted. It is dotted decimal notation. So we call this dotted decimal notation, decimal, binary. Now some of these things, when we reach here, now we have 4 octets of an IP address. There are 4 octets. 4 octets, what I mean, we have this octet 1, octet 2, octet 3, octet 4. But in each octet, we have 4 bytes. So 4 multiplied by 8, you end up with 32 bits. In each byte, we have 8 bits. Yes, that's why we are having here 4 bytes, 32 bits. These 4 bytes are for each octet you're seeing here, So how do we represent 192? So let me show something here small, how we do that easily. Let me share. I would like to share. I hope you can see my screen when I do some drawing here. So how we do this, we have 128. No, let me just text this. Text here. Hope you can see what I'm doing. So we have 128, we have 64, we have 32, we have 16, 8, 4, 2, 1, like that. So how we represent two? So we are using these values 128. I'm forgetting the particular name for this, but yeah, this is what we use. So if we are looking for 192, how do we present 192 in bits? So 128 plus 64 gives us 192. So the rest we shall put zeros like that, 0. We shall represent them with zeros. We shall realize that these are either host bits or network bits. But for now, this is how we represent them. We use a 1 to represent a value. So if you add 128 plus 164, we end up with 192. So you're seeing it being represented here. Now how about 168? Meaning for 168, I want to go back to the previous one. Okay, let me do another one here. Okay, 128, 64, 32, 16, 8, 4, 2, 1. So what shall we do for 168? So for 168, what shall we need? You shall need 168 minus 128. You put here 1 like that. Wait. So 168, how do we represent it? So if we get 122 plus 64, we shall go back to 192, but we are looking for 168. So we shall get 128. For 64, we shall put a 0 because we don't need it when you're getting 128. 32, we can use it. We put there a 1. So if we get 128 plus 32, what do we get, guys? 160, right? Hope we are following, guys.
Yes, we are following.
Okay. So now 128 plus 32, we get 160. So 160, we are remaining with 8, and 8, we have it there already. So I go there and put that 1. The rest we shall have 0. We shall have 0. Zeros here, elsewhere we shall have zeros. Like that. So even the other number is the same. You're seeing that for 1, we're having a 1 here, the rest are zeros. Like that. Okay, so now with powers, power 2, power 7, so 128 to power 7, you get 128. Like that, like that. So what's below here? So how do we present the IPv4 address range? It ranges from 0 to 225, but how we represent that in octet form? We represent it in this format, in octet form. We represent that in octet form, 0 to 255. So you're saying this is, as I've told you, octet form, 4 octets for an IPv4 address range. We use 4 octet. So this is how we represent it. And this is the last address. All right, so let's continue. Okay. IP address structure. We have a network part that identifies a network and a host part that identifies a host and is used to differentiate hosts on a network. So within this octet for an IP address, IPv4 address, we have a network part and a host part. What does the network part do? We shall find out that. What does the host part do? What is in the host part? So the other thing we have also, we have a network mask. For it, it is used to distinguish the network part from the host part in any IP address. So it's from the mask that you get to know which one is the network part on this IP address structure, which one is the host part. So from this, we shall represent all these values here, these ones in octet form, in bits. So you saw that you saw we did this. So I won't say much here. I won't say much here. You get? So now the network apart from this structure starts from here to this side, and the host part starts from here to this side. So if we represent this in bits form, this one will be represented like that, and we shall also get the network mask. Now for this case, the network mask is 2255, 2255, 2255. And 2255 is a /24. Why /24? You count the bits. These bits here, 8 plus 8 plus 8, total up to 24. So that's the reason why we have /24. You get, so once you have /24, you definitely know that the network part is having 3 octets, meaning there are 80 bits multiplied by 3. And that gives you 24, /24. We shall get no /24 is which class, once which that part of classes of IPv4 addresses. Now the host part is this one here. The rest of the other part that is not under the network part is the host part, this. So for this slide, it was just briefly telling you the main parts we have on an IP address structure: network part, host part, and the network part that is able to help you differentiate which one is the network part and which one is the host part. Okay, network part in bracket network ID, it identifies a network. Host part identifies a host and is to differentiate hosts on a network. So network part is like a community, a class, a group. You get, like this particular group of people can use these IP addresses. Yes, but host part, it's like in particular, the IP address of a certain person. Host part, like with this community, this guy, .x, .y, .z. This will be an IP address that belongs to John, that belongs to Peter. You get? So if I go back, let me go back, like you see here, it's a .1. A .1 will be, now the whole of this will be an IP address for one person. But in this IP address, you have a network part and the host part. So as we said, .1, .2.3. Those will be different IP addresses for a particular person. That's why from this other slide, they're trying to show you that a community A and number X is street Y, John. Now here you're being specific. The host part helps us to be specific. Okay, so now here they are trying to show you layer 2 network addressing. Now this is like a home or a company. We give them like we give them a community A. That's like the network bits to use. This is like a community. Then if we come to layer 3 networking, we have a router in there that is interconnecting the two different layer 2 networks, as you can see. Now this is the layer 3. Oh, wait. Layer 3 networking addressing. That's how it looks like. You're having a router in the layer 3 device that is interconnecting two different layer 2 networks. But for this one here, it's particularly layer 2 network address. You get? You could even be having here a router, but you're in one network, like it's having only one attachment, one network on it. But now for this other router, it has two networks and it is interconnecting. So once it's doing the interconnection, we call that one layer 3 network addressing. Now, the other thing I can talk about on this slide also, .0 represents a network. That's why we're saying .0/24 represents a network. Like, don't look at this as only one user or one PC. This one here is showing here a network address, meaning in here you have .1, .2, .3, .4, .5 up to wherever, like depending on the list network mask. This one is representing a whole network, meaning in here you have people who have .1, .2, .4, .6, like that. Now on this interface here, you have a .1 because it's just an interface, one interface, but it's also under the same network. So it's having a .1, meaning this 10.0.1.1 is an IP address for this interface here. The same here, .2.1, it is an IP address for this interface here. But within here, this one, we're having .3, .4, there are many in here. You get? Don't look at this as a one-to-one connection. All right, we got page 18. Now here we go, talking about classification, classful addressing. To facilitate IP address management and networking, IP addresses are classified into the following classes. We have class A, we have class B, we have class C, we have class D, and class E. Now, how do we represent? How do you get to know? How do you get that this is class A? Now, normally after you turning the IP address, as we've seen on the previous slides, into bits, like bits, you know that for class A, it starts with a 0 here. With class A, you get to know that. With class B, it starts with a 1 and a 0 like that. Class C like that. Class D like that. Class E like that. Then what are their ranges? They have their ranges because we remember from our previous slide, we said it's from 0 to 2255, but you represent that in an octet form from 00, this one here, from this, remember from our previous slide, from this was the range to this one here. But within this range, you have classes. So meaning class A ranges from 0 to 127, as you can see here. But how do we present that in octet form? It's what they are showing you here. Now for class B, 128 to 191. But this is how we represent that in octet form for the IP address, because an IP address has 4 octets. Now for class, it's from 192 to 223. For class D, it's 224 to 239. And the other one, lastly, class E, 240 to that last one. Now they're trying to show you that in practice, we use only class A up to class C. Okay, we use all of them, but they all serve different purposes. From class A to class C, that's where we are able to assign hosts each and IP address. So we make use of class A, class C. For other classes, class D is used for multicast. Multicast shall get to understand that in detail. Multicast is like you're sending to a particular group of people, or you're serving a particular group of people on a network. So you would want all that particular group to receive information. Once you send information, maybe to like Chamberlain University, it will only go to the staff. You get, that's multicast in a layman's language. Now for class, it's for research. Yes, we had talked about all this here. So we realize that for class 8 / 8, meaning these are 8 bits. It's a class 8 is /8. So for class bit /16, yes, those are 16 bits /24. Those are 24 bits. So we realize that for /28, meaning the network part, hope someone is now following. The network part will, if I have a network, let me say x dot x. Oh, wait. Dot x dot x dot x. So once I say it is let me change here something. Once I say it is /28 bits, meaning the network part starts from here, going this side. This will be my network part. And this will be my host part, the rest, the others. This will be my, this other part will be my host part. So if we set /16, meaning this time around it will start from, here. /16, these are 16 bits. Meaning for this, it will be now /16. /16. Now, if we go to /24, meaning, I hope you're not forgetting this, meaning this other part, this now, the whole of it is a network part. Okay, so lastly, if we go to /24, meaning the whole of this now will be /24. And implying the whole of this is network part. I mean, this remaining one is the host part. Yes, this one is the host part. So from the previous slide, you realize that the IP address example they gave us was a class C. Let's go back briefly there. Wait, why is it not? You see that address 192.168.10.1, that was a class C address C. Okay, IP address types. A network range that defined by network ID is called a network segment. Network address identifies a network. So remember when I was telling you that .0 is representing a network. So we call that a network address, so a network ID .0. You can't give .0 to someone. You get, that one is like a name to representing a network, as we saw here. This .0, 1.0, this one is representing a network. When someone can't tell you that I have a network, my IP address is .0. No, it can't be .0. .0 represents a full network. So you see even here it is 2.0, meaning the whole of this representing a network. That's what they are trying to mean on this other slide. Here, identifies a network, that one, the .0. If you represent that in bit form, this is how it looks like in bits. Broadcast address is a special address used to send data to all hosts on a network. So if you want to send to all hosts for a particular network like this one here, .192.168.10.0, you can only send to 10.255, implying that you're sending to whoever is in that network the information. And this is how we represent that 1111111, and realize that 11 actually, it implies that we are adding all the other numbers that we had done before. This one is here. We are adding 128. 128, 64, 32, 16 to represent that 255. 8, 4, 2, 1, meaning we are adding all of that. That's why we are having a 1 there, a 1 here, a 1 there, a 1 there, a 1 there, a 1 there, 1 there, 1 there. Meaning if you add all of that, that one is represented by a 2555. Now for the 00, it is the opposite. 0 meaning nothing. So you won't have any the 1 anywhere. They will all be zeros. Okay, in bits. Now available addresses, that one is the one we allocate, meaning in between these, the 1.1.2.3.1 representing them in bit form, it is like this. For this example, .1, it's like that. Now that's like the available IP addresses, meaning if the try to calculate the number of IP addresses available or for the hosts, you have to always subtract that too. That's why here in the note here they are telling us network address and broadcast addresses cannot be directly used by devices or their interfaces. And number of available addresses on a network segment is 2 power n minus 2. N is the number of bits in the host part. So you get the number of bits in the host part, power 2, 2 power that number minus 2. You have to move the other 2 addresses. Don't include them once you're telling your boss or your network manager if you are an employer. You should subtract that too, because network address is just a number. It identifies a network. It won't be allocated. And the broadcast address, you've seen its purpose. And there will be rare cases when we shall have to send data to all the people in the network. So you have to always calculate and remember to deduct that too. All right. Wait. So let's go to wait, I want to clear something here. Yes. Example. Now this example is for your own good. There are more other examples. Let's go through this other one. Okay. What are the network address, broadcast address, and the number of available addresses of class B address 172.16.10.1/16? Now, meaning if you practice these things a lot, or if you read to understand in detail, or if you read more and you keep going through these things, once you see 172 to your mind, you'll get to know which address is that. You have to remember, okay, 0 to 127, that's class A. Now class B is 128 to 191. So 172 is within that range, so that's class B. So IP address, as usual, this one now it comes to your mind. Once you see /16, you know that those are 8 bits plus 8 bits, meaning from here to this side, that's the network part. Now the host part comes in from this side to the other side. It's the last one on the 4-octet structure. The network mask, they are showing it /16. So you put in bits form, that's how you represent the network mask. Hope you can see it here. Network mask, that's the /16, that's how you present it. 16 bits, you put them there, 8, the rest are zeros. Here, this is how you represent 172 like that. You remember, 16 like that. So the network address is obtained with all of host bits set to 0. Meaning for the network address, this is a class B address .1. It's for someone on a network .1. They are reminding you for the network address, all the host bits in this host part, wait. In this host part, this side, coming this side, we have to represent all the bits in with a 0, with zeros. That's what you're seeing here. Once you come to network address, it will be now 172. Wait, Now from this you get that 172.16, meaning that as I've told you 172.16, that part is now these are 16 bits, meaning that part is the network part, what I've just typed so far. Now, how do we present the network address for this? We represent the host part with zeros. But now me, I'm representing this in an octet form. How do we present this in bits form? This is how it is represented, what you're seeing here. Here, network address. This one here is 172, but they have put it in the bits form. This one is 16 in the bits form. Now these are the zeros. It's a zero I have here, the zero I have here, and it was typed here, it is here by the here, like that. Now, how do we present the broadcast? We do the opposite. We present all the host part with bits, ones. The ones you're seeing them, meaning you have .255.255 as the broadcast address for this case. Now, how do you calculate the number of IP addresses? 2 power 16. 2 power 16. These 16 are the host bits you're having this side in the host part. That's why we are saying power 16. The number of host bits you have this side. That's the 2 power 16 we have there. But you have to subtract the 2. The 2 is not needed. These addresses here, the network address and the broadcast address. So meaning this is the number of available IP addresses, the range of available IP addresses. So meaning it will be .0.1 to 172.255.254. You know the reason why you're saying 255, because 255, you subtracted it and it's not needed, and it is here. It is here. Yeah, if you want to understand these things, the more you have to keep practicing, because I'm sure there are more examples in that PDF I shared. Okay. Guys, any question before we... Hey, this one looks like a church. Any question? Before we go to private IP addresses, Any question, guys? Oh, do I have people inside here?
Yes, we are here.
Okay, now any question? Let's have a short break. We shall get back at exactly 6:35, just 5 minutes. Okay. Yeah, let me take some water and I come back and we'll resume. Guys, you will rejoin in. I'm going to, we shall use the same link still. Don't worry. But in 5 minutes, you log in the 5 minutes, you join. When it is like 6:36.